Today we're going to be going over homework problems with permutations, and after you see them worked out, you'll be able to figure it out yourself fairly easily. If you haven't already, please subscribe to this channel. Let's begin now on MathCat. 3, 2, 1. Let's look at this problem. How many three-digit numbers can be made from the numbers 3, 9, and 1? Since order matters, 391 and 193 would be two different numbers, so order matters, so we're looking at a permutation, not a combination. We have to determine for our formula, MPR equals n factorial over n minus r factorial. We have to find what n and r are, and n is the number of things in our universe. How many things do we have to pick from? And R is the number of choices that we're going to be making. Our universe are the numbers 3, 9, and 1. So N is 3. There are 3 different numbers to choose from. And we're looking to make 3-digit numbers. So R is also 3. So we're looking to make 3-digit numbers from a universe of 3 numbers. So we're looking at the permutation of 3 things taken 3 at a time. N factorial over n minus r factorial. N is 3, so we have 3 factorial over n minus r factorial. 3 minus 3, because r is also 3, factorial. Now 3 minus 3 is 0, and you see 0 in the denominator, and you think that can't be done. But 0 factorial is not 0. 0 factorial is defined as 1. So what we actually have is 3 factorial, which is 3 times 2 times 1, over 0 factorial, which is 1. And 3 times 2 is 6 over 1. So we have 6 ways, or 6 different numbers that we can make from the digits 3, 9, and 1. Let's try this one. How many ways can 3 class officers be selected from a class of 16 students? So we have 3 offices, like president, vice president, and representative, and the same student could be in any one of the 3 positions. So order does matter, so this is a permutation. So our formula for permutation is n factorial over n minus r factorial. N is the number of things in our universe that we're selecting from, and in this case we have a class of 16 students to select from, so n is 16. R is the number of things we want to select. We have 3 class offices, 2, 3, so R is 3. So we have 16 things in our universe, and we're selecting 3 at a time. The permutation of 16 things taken 3 at a time. N is 16, so we have 16 factorial, n minus r, 16 minus 3, or 13 in our denominator. So we have 16 factorial over 13 factorial, and if we expand that out, 3 times 2 times 1, and 13, everything cancels from 13 on down, and we have 16 times 15 times 14, which is 3,360 ways we can select 3 class officers from a class of 16 people. Let's try this one. How many 4-letter arrangements can be made from the letters A through L? Well, this is a permutation because every combination of letters can be switched around and order does matter. So we have to determine what N is, our universe of letters, and then R, our selection of how many we want at a time. Well, the letters A through L. You can go A, B, C, D up to L, and you'll find L is the 12th letter. So we're talking about 12 letters in our universe, and we want to see how many 4-letter arrangements there are. So we're going to be choosing 4 at a time. So R is 4. N is 12, R is 4. Our formula for permutations is n factorial over n minus r factorial, which n is 12 factorial over 12 minus 4, or 8 factorial. So we can expand this. 12 factorial is 12 times 11 times 10 times 9 times 8 times 3 times 2 times 1 all over 8 factorial, which starts here. Nice little shorthand way to show you this. And from 8 on down, all the numbers are going to cancel. So we're left with 12 times 11 times 10 times 9, which is 11,880 different arrangements of letters, 4-letter arrangements for the 12 letters A through L.